Alright, here's a video on surface mount soldering. Now, surface mount soldering, for those who have never done it before, it's going to seem intimidating. When you look at the size of these components, they're actually quite tiny. Alright, now just for a size comparison, let's see, for those of you who know what hard currency is, that is a penny. So you can actually see, compared to it, that's about the size of Lincoln's nose. So we call that awfully tiny. Trying to remember what size this is. It might be 0805, certainly not 1206. Could be 0603, but I forget. I made this kit a year or so ago. So surface mount soldering is called that because it's soldering that's done on the surface, as opposed to, whereas this is a through-hole component. So this is actually the little 2-pin header. So this is made to go into the basically just the breadboard power rails, so you can actually plug this in. And this is a 555 timer circuit that all it does is that there's a little LED here. This is an unstable multi-vibrator, and it just blinks the LED on and off. So the advantage of surface mount soldering is manifold. One is that you've got significantly smaller components. So if I built this on using through-hole components, it would be much larger. The components are much larger. They take up a little bit more power. The LEDs take up a little bit more power as well. They draw more like 20 milliamps, and this draws, I don't know, just about 4 or 5 milliamps. Could draw up to 20. But it takes off. It takes much less area on the printed circuit board. Also, when it's being manufactured, a very fast pick and place machine can come and pick these up off of a long tape and reel, and then place these very precisely. It has a much better parts density. There's some parts that today they're just not made in through-hole. It's made all surface mount. If you think about it, if you're a company and you want to sell millions of a particular product that you've made, or a particular chip, you want it to be in every cell phone that's out there, you're going to make it as small and tiny as possible. So one of the things that you'll come across is that you might not be able to put a component onto a breadboard very easily. So being able to surface mount solder is becoming an increasingly necessary skill. So this is just a pretty simple board. We're going to do I'm going to show you how to do it with a regular soldering iron. I think it surprises people that you can actually solder all of this with a normal soldering iron. So normal soldering iron being something like this. I think this is a 2mm chisel tip. So it's called the chisel tip because it's wider in one dimension than it is the other, and it looks kind of like a chisel. Now it's a pretty simple technique. Basically what we're going to do is we're going to put solder on one pad. Then we're gonna, with one hand, we're gonna hold the component in place. Then we're gonna bring the soldering iron back in, remelt the solder, and so basically tack it down in place. Then we'll come back and then we'll just solder the other component. Now, one of the things that's also fairly critical is actually the kind of solder you use. So this is a fairly thin solder. I think this is 0.031 or this is 0.015. So this is very thin. So the idea being that you want to be able to control the amount of volume that goes onto this pad. So if you have really thick solder, you can imagine if you're just pushing a little bit, you're just going to get a much larger volume. It's going to be harder to control. And so with a thinner solder, it's much easier to control the amount of solder. Another thing that really becomes important is something that's called flux. So this solder actually does have a little bit of flux in it, but when you're soldering such small components, that the solder might actually just smoke off really quickly, and then when you want to go and reheat it, that it becomes the solder doesn't flow as well. It doesn't, forms these little little horns that come up. We'll see under the microscope. Maybe I should be able to do that. And so this is one of those things that when I discovered this, it was basically a life-changing moment. I became a board-again solderer. It makes life so much easier. It makes the solder work the way it really should. And if you've been soldering for years and you've never used this stuff, let me tell you, you're missing out. So we'll actually be able to see that in place. And if you're familiar with Louis Rossman's YouTube channel, we are not going to use quite the volume of solder flux that he does. I think he charges his customers based off of how much flux he uses. So anyway, so we can actually see. Let me start recording with the microscope. So now as you can see over in the microscope, that these, let's see, here we got resistor, what's that, R1. So it actually has very tiny printing on it, 1, 2, 3. So this is going to be the same like the colors. The first two numbers are going to be the unit, and then the last number, the third number, is going to be the multiplier. Sometimes you might have like a 1000. That's just going to be just 1K. You might also have 102. That also means 1K. So this is a 12K resistor. We're going to take that off. And then another thing to note is with the LED, you might be able to make out. So up on the left, right next to the 1 on the component itself, you can see is kind of green strip. That tells us that is the cathode side. And so this on the silk screen, you can kind of make it out. It didn't quite print out as much. You can see that this is the symbol for the LED or the diode. And so this also points to the cathode side. So what we're going to do, we're going to start, let's actually start in the middle. So for the integrated circuits, so this is called an SOIC 8. So SOIC stands for Small Outline Integrated Circuit, and the 8 is the number of pins. Now you'll have ones of different dimensions. This one's a little bit wider. You might have some that are a little thinner. Both will be like SOIC 8. Then there's going to be like 16, so that's going to be the same thing, but with 16 pins. So basically what we're going to do, we're just going to tack one of the pins with solder, and then we're going to use the tweezers, which is one of the most important tools for surface mount soldering. You want to get ones that really come down to a point. Then it's very important that these things are kept sharp and clean. You can actually feel there's a little bit of stick at the end. You can maybe see that little, kind of looks like a blob. Maybe a little bit of a blob. That might be a little bit of dirt or solder flux. Let me see if I can clean that off. Yeah, I can even feel it. Well, hopefully that won't be a problem. So this could be one of the things that is, a little bit of hand-eye coordination is important. But what's really key, I find, is actually using, resting your arm on something or resting your hand. So if you're holding your hand up in the air, you're obviously going to wander around a little bit. But if you rest your palm, not the palm, like the side of your hand right next to it, then you have a lot better control. Like you're using the muscles in your finger, not your arm, to move things around. So I can get some pretty steady movement. A little bit of shaking there, but so the key is really just anchoring your hand. So the closer you can get to the work, the better. Even the closer you can get on the tweezers is better. So all right, enough talking. Let's get to soldering. So I'm going to take this thin leaded solder, none of that lead-free rubbish. So I'm going to, let's see, I'm right-handed, so I'm going to just tack this down. So like soldering, normally you apply the heat, apply a little bit of solder, pull the solder away, pull the heat away. So now I am going to take tweezers. Let me move this stuff out of the way. So I'm going to take tweezers. I'm going to hold this, and I'm going to line it up. So I'm actually kind of holding it against, and basically want to line up as well as I can all 8 pins, and come in, remelt the solder, hold it. Oh, didn't get it. Let's try that again. Right about there. Hold it, hold it. All right. Not too bad. So that's one of those things that might take a little bit of practice. And so basically what we're going to do, if I can do this without moving things around, I can go around the other. Actually, I'm going to start soldering here. So this is just, you can actually, it might be better to solder the other side first. So I'm going to apply some heat. A little bit of solder. All right, let's see if I can actually maneuver this around. Alright, so I'm around the other side. I'm going to apply some heat. Put a little bit of solder. And pull that away. So that's pretty nice. So now it's actually pretty nicely anchored. So you can actually see it's not going to move. So all I need to do is go around and hit the other pins. Go doink. Touch both. Solder. Well, I got that last one by default. Alright, now I'm going to hit the other side. Now, right hand is a little bit easier. You can actually, so we'll go in. Let's just start up here. We'll just go in and heat. Solder. You can actually pull away, helps. And apply heat. Oh, it's a little extra solder on the tip, so that helps. Go in heat, solder, pull it right straight out. So now if we zoom in with the microscope a little bit, let me put the soldering iron down. So if we zoom in, let's see if I can do this without getting in the way. So I can zoom in. That's actually not that bad. Let's see if I move the microscope. Can I do that? I think on this next one up. Oh. Helps to loosen the right thing. There we go. Yeah, so. No, come on. Work with me. Okay, so the one in the middle, let's see if I can get this even more. And you can actually see a little thing poking up. So what we're going to do, we're going to go in with a little bit of flux. Again, we're not looking at Lewis Rossman level. You know, we'll just put a little flux on the other side. And we'll go back in with the soldering iron. And we're just going to remelt. Just pull it away, pull it away, pull it away. So that makes for a much nicer soldering point. So let's zoom back out. Oh, that's focus. So let's zoom back out. So you can kind of compare the sides and refocus. Rotate the camera. Alright, so let's go hit the other side. So I'm going to, let's, let's recenter. I'll focus. Alright, there we go. So you can see the left side's not too bad, but you can see the, I think, hopefully you can see it in the camera. So you can see this side is much smoother, it's much, much shinier. Yeah, so we're just going to go back over here and just remelt everything. Pull straight out, pull straight out, pull straight out, pull straight out. So, that's just like that. We've soldered our first integrated circuit. Now I'm actually going to go through. Let's actually tackle C1. So again, all I'm going to go do is apply a little bit of solder. Let's actually go and just dab all over them. Nah, screw it. Let's just do one at a time. All right. So I've got my component. And I'm going to go up there. So I'm going to kind of hold it over the middle as much as I can, as well as I can. And remelt the solder. Hold it for a second. And that's not too bad. And so what I'll do, take the solder. See if I can do this. So I'm going to apply some heat. Some solder. Come on. Oh, helps to touch the board. And like that. A little blobby, a little too much solder, but we can actually clean that up. So I'm just going to go around and dab R3. Let's dab D1, R2, and R1. I probably put a little too much solder on some of these. That might be a little too blobby, but that's okay. We'll make it work. And we take the component, the tweezers, hold it over there. So I'm also actually kind of pressing down on the PCB to actually help hold it in place. And I'm just going to apply some heat. And there it refroze. Alright, so I'm going to move those out of the way. Oops. Take the LED. Yep, see. Yeah, balls. Going to hold that. That's pretty good. Apply some heat, make sure I touch the LED itself. And let it refreeze. Alright, I'm happy with that. So we take R1. And remelt, refreeze, and R2, and get it a little bit centered. Touch the resistor. All right, it could be straighter, but I think that's good enough. Now we're going to go through as much as I can. I need to add a little solder. Let's see. Zip around, clean off the tip. Spray on the other side of the LED. Apply some heat. Some solder. And we'll hit R1. And then R2. Oh, see that one actually moved. Yeah, so the component's small enough that I can actually apply heat to this side and get the other side to melt as well. Oh, see? That made a nice little horn there. And so what I'm going to do, I'm going to grab some flux, and I think I'm going to just dab a little bit here. You know what? It'll just channel a little bit of Lewis Rossman. Just go a little crazy here. We'll clean this up. Alright. So what this should do, the excess solder should just wick away. So I'm just going to go around, hit this one with the side. Yeah, maybe not. Clean that up. This is also going to help the solder kind of get underneath the tabs. Make a better connection. It's not like we've made a bad connection, but this is just going to make it a little nicer. Alright, now all we need to do is clean it up. Alright, for that I'm using these little, I guess you can call it like a Q-tip kind of thing. Let's see if I can get that under. See, that's actually kind of spongy. So this is actually something that's designed to do exactly what we're doing. So we're going to use some isopropyl alcohol. This is a lint-free. It doesn't generate static, so it's safe for electronics. And so it's essentially a Q-tip, but something specifically designed not for your ears, but for your electronics. So of course we're going to use just a little alcohol dispenser. This is one of those things where alcohol does in fact help solve our problems, as opposed to the emotional ones. So I'm taking a little Kim wipe. I'm going to put it over top, and we're just going to dab it and kind of rub it around. So the idea is that the Kim wipe will actually pick up the flux residue, and the Q-tip will actually act as more of a kind of, I guess, a repository or a dispenser of the alcohol. So I'm using 99% isopropyl alcohol, and finally just kind of give that a nice little rub with the hand. And that's well, that's a cleaner. Let me just go back in, just give this a nice once down. So this probably isn't going to get all of it, but it should get the majority of it. So we'll actually see the alcohol evaporate. So that's what 99% alcohol does. Nothing but the good stuff around here. All right, and that is surface mount soldering. And I'll probably show the circuit working. All right, so to finish it off, we've got to do just 2 points of through-hole soldering. Now don't worry, this is just as easy as surface mount soldering. So all we need to do is we're going to go in there with some heat, add the solder, watch the flow, pull the heat away. Now after pulling the soldering away, apply some heat, apply the solder, pull the solder away, pull the heat away. And just like that, our little circuit works. Alright, and there is the working stable multi-vibrator blinking LED. I hope that inspires everybody to do some surface mount soldering, or at least not be afraid of it.